So let's look at example number 2 that deals with Hooke's law. So one end of the spring is attached to a ceiling. If the yield point of the spring involves a mass of 1,000 kilograms, what is the limit of the distance our spring can stretch, knowing that a force of 300 newtons stretches the spring by 2 centimeters? So we basically want to use part 2 of our problem to solve for part 1. So in part 2, we know that if we apply a pulling force of 300 newtons on our spring, it will stretch a distance of 2 centimeters. So knowing this and using Hooke's law, we can basically solve for the spring constant or Hooke constant of our spring. And then using the spring constant, we can solve for the limiting distance of our spring. So let's begin in part 1 by simply writing out our formula or Hooke's law. So the force is equal to negative of the constant, spring constant, multiplied by change in distance. So let's plug in our values. So we know that a force of 300 newtons, so we plug in 300 newtons equals the unknown, our case unknown, multiplied by our centimeters. But we have to use meters because this spring constant has to be in newtons per meter. So let's convert our centimeters to meters by simply dividing this by 100, because there are 100 centimeters in 1 meter, and we get 0.02 meters. We bring this guy to this side, we get 300 newtons divided by 0.02 meters, and that gives us 1.5 times 10 to the 4 Newton per meter. So this is our constant of our spring. So now that we know our spring constant, we can use that information to solve for our maximum distance that our spring can travel before it reaches the yield point. So first, let's find the yield point. We can find the yield point by simply plugging in our 1,000 kilograms into our force. So our force is simply the force of gravity. So if this object is 1,000 kilograms, then this spring feels a force of 1,000 times 9.81 meters per second. So we get 1,000 times 9.81 equals something that we now know, our spring constant, 1.5 times 10 to the 4, multiplied by the distance that our spring will travel. So we bring this guy to this side and we get rid of the negative. In this case, the negative is not necessary because we're not solving for direction. We only care about our magnitude. So we basically use a calculator, divide this by this, and we get our change in distance is simply 0.654 meters. So our yield point will be reached when 1,000 kilograms will be attached to our spring, and at that point our spring will travel or displace a distance of 0.654 meters. Now at this point, if I take off my mass, remove my mass, my spring will not go back to its initial position. And that's because we have now reached our yield point. So what that basically means is the following. If we attach a mass of anything less than 1,000 kilograms, our spring will resume its initial condition or initial position after we remove that mass. But that mass has to be less than this mass. So that means that if that mass is less than 1,000 kilograms, the distance will also be less than 0.654 meters. So our maximum distance that our spring can stretch before actually reaching the yield point has to be less than 0.654. So it could be 0.653, 0.652, and so on. But it has to be less than this amount.